Okay, so let's move through part B. What will be the velocity of the electron on reaching the positive plate? So this is where the equation up here, let's highlight up here. Oh yeah. This equation that I introduced can be helpful. So we know then that, get back to blue, which I prefer for this. So we know half mv squared is equal to qv. So this is an energy conservation equation, really just saying that the kinetic energy will be equal to however much work was done due to the voltage difference or due to the electric field, which is, they're sort of saying the equivalent things. We've already done the calculation for the right hand side of this equation, so we can put 3.2 times 10 to the negative 18 here. And on the left hand side we have 1/2 times m, so this is the mass of the particle, and in this case we're talking about an electron. We've been given the mass of the electron in the stem of the question, which is 9.11 times 10 to the negative 31. And then we have times v squared, and v is what we're solving for. As always, remember, write the equation that you're planning to substitute into. In general, you won't get a mark for that, but it will help ensure that you do get a mark for this step where you substitute those relevant values in. And then we can rearrange to solve. So 2 times 3.2 times 10 to the negative 18, the multiplication by 2 here is just because of the half that we had on the left hand side, and then divide by the mass, 9.11 times 10 to the negative 31, and then taking the square root of all of that, that should give us So our answers have 2.65 times 10 to the 6, just because of the fact that we are limited in the charge we've used and also the voltage. They both have only 2 significant figures, so I'm going to give our answer here also to 2 significant figures. So 2.7 times 10 to the power of 6 meters per second.